interpolation, linear interpolation, in which we are tracing the linear line, and from that we estimate the data from 2 data points, x0, x1. If you have 3 data points, then you take second order interpolation, which is called quadratic interpolation. And for that we have seen that the error increases as you increase the order of interpolation, right? And then I gave you one example for the assignment. So today we should start so today we should start on this Newton's divided difference interpolation. Newton's divided difference. So you have gone through this in your mathematics course. So there are 3 types: Newton divided difference, forward difference, and backward difference. So we'll just take up this example of divided difference, and we'll see how to estimate the data, and we will also compare the error compared with the Lagrange interpolation, whether it is more accurate or not. So in that case, we need to take actually 6 significant digits for that. So the general formula for the Newton's divided difference interpolation is first to obtain your function from the given data. So you have the given data x1, x2, x3 up to xn. For that you have f0, f1, f2, f3, and so on. So from that, how you can obtain the equation? So x minus x0 into f of x0, x1 plus x minus x0 into x minus x1 to f of x0, x1, x2, and so on. You can increase the order. And what are these f of x1, x2 or x0, x1, all this? So you take simply the divided difference. So for example, for f of x0, x1, you simply just take the difference of the functions f1 minus f0 divided by their corresponding coordinates. So that is x1 minus x0. Right. Similarly, if you have 3 points, so you take the difference between x1, x2. Let me just write down. So x0, x1, x2. So that is f of x1, x2 minus f of x0, x1 divided by x2 minus x0. All right. And similarly, if you have third x3, then you will have x1, x2, x3 minus x0, x1, x2. And again, both this will have this type of formula. All right. So one can obtain such type of estimates from the given data. So we'll just take an example. So that will make more sense. So I think we should take the same example so that we should have an idea. So for what? So we are taking the example of ln of 9.2. I mean, you have the data of ln of 9 and 9.5 and so on, and from that we estimate what should be the data value for this particular value. I mean, ln of 9.2. So for that, I should make something table like. So let's say you have the data which is given to you, which I called xj, and over here I would just say you have 8.0 and you have 9.0, you have 9.5, and you have 11.0, and the corresponding f of xj. So these are 2.079442, and for ln9 you have 2.19725, and ln9.5 you have 2.251292, 2.397895, 7895. All right. So now the question is to find out the value of this. Okay, so or if I would say f of 9.2, we want to find out the value for this. Okay, so for that I will, okay, so that's your x naught, that's your x1, so x2, that's your x3, and according to this formula I would first obtain the equation in the form of f of x, then I should substitute x equal to 9.2. So for that you will need all these differences, I mean all these functions, f of x naught x1, f of x naught x1, x2, and because we have third digit x3 as well, so you will have to find out these f of x naught x1 x2 x3 as well. And also, so that is one way to do, I mean this is the way that we proceed to find out these function values first. Okay. Now there is another way, because this may be a shortcut, so you might have done all these things, but just to revise it again, f of x j x j plus 1, and then you have f of x j plus 1 and x j plus 2. Okay, and you will have one more. So I'm not writing this whole thing. अच्छा, इसको ऐसे भी लिख सकते हैं that you may find it in some book, delta f of x naught, you know, delta square f of x naught, and delta cube f of x naught, yeah, or xj, I mean because the initial value is x naught. So you may find also this instead of this. So initially simply you take the difference of these two divided by difference of these two. So 2.1 f of x naught x1, or this is your delta of xj. So f of xj is equal to, this is simply the difference of these two by these two. So 2.197225 minus 2.079442 divided by 9 minus 8. Okay, so difference of these two, and this number whatever you are getting, so that should be put up in between these two. That I am just directly writing the answer. Okay, because this is, as I said, this whole unit is going to be like this. Simply you are going to use a calculator to estimate the values. 0.117783. Yeah, there is a difference of these two. Similarly, you have a f of x1 x2. So this difference of this to this minus this to this. So 2.251292 minus 2.197225 whole divided by 9.5 minus 9. So whatever difference you will be getting, so that you substitute over here, which is 0.108134. Right. Similarly, the difference of these two, I mean first this f, the functions divided by its coordinates. So difference of these two divided by this difference, so that should give you 0.097735. So that is your f f of x not x1, first order, so delta f of x j, actually it should be x j. All right, so somebody's mic is on. Can you please switch off the mic? So we have this differences that you have obtained. Right now we will follow the same thing, and because this is the divided difference interpolation. So divided difference interpolation. So you take these differences, and now you will skip one data between your initial guess. I mean initial given data जो है उसमें से एक data है आपको skip करना है. So now what you will be doing so that you will take the difference of these two divided by 9.5 minus 8. So for example, delta square f of x j. So for first coordinate, you will have 0.1081, 0.108134 minus 0.117783. So take the difference of these two divided by 9.5 minus 8. So 9.5 minus 8.0. All right, that will be for the first coordinate. So you take the difference of these two, and that you obtain over here. Okay, so that value I am writing it down directly 0.006433. ठीक है, ये दोनों का जो divided difference है. And similarly for this, you take the difference of these two divided by the difference of 11 minus 9. 11 minus 9. So that should give you minus 0.005200. Okay, ये दोनों का difference है divided by these two difference 11 minus 9. All right, so that is your delta square f of x j, and at the end delta cube. So delta cube f of x j would be equal to last one. So now you will skip two data points. So that means 11 minus 8 ये रहेगा. So you will have this minus 0.005220 and minus this, so minus minus plus 006433, 0.006433 divided by 11 minus 8. 11 minus 8. ठीक है, so ये जो difference होगा interpolated value, that value is somewhere close to 0.000411. Okay, so you upload, you just verify on your own all these values. Okay, so once you make the table, then you simply plug in the values in the equation. The equation. So I'm going to write down somewhere here f of x is equal to, first you will have f naught. So f naught, I will directly just write down f naught, that means your initial 2.079442. 2.0794442. ठीक है, plus x minus x naught into f of x naught x1. So that is your initial, this is delta f of x naught. ठीक है, ये वाला होगा delta f of x naught, and that you substitute. So you will have plus x minus x naught. So okay, so instead of x, I will just write down 9.2 because that is what we are working upon to find out the value of 9.2. F of x equal to 9.2. So 9.2 minus 8.0. Okay, that is x minus x naught into f of x naught x1. That is going to be the first divided difference, 0.117783. 0.117783. Okay, plus now you will have x minus x naught minus x naught into x minus x1. So 9.2 minus x1. So x1 is 9.0. So that is 9.0 into the second divided difference interpolated value. So that means this one, 0.006433. Actually it's minus, so minus 0.006433. All right, and then you will have 9.2 minus 8.0, 9.2 minus 9.0, and 9.2 minus, you will have f of x2, that is 9.5. 9.2 minus 9.5 into, they'll capture the last divided difference, that is 0.000411. 0.000411. Okay, so this is just simply using a calculator and to find the values. So one can find the values of this particular. So this is your f of 9.2, and so just remember that we are doing this first order, second order, and third order. So this is third order polynomial. Newton's third order polynomial. So according to this calculation, अच्छा आप लोग बताइए what answer you are getting for this, and then we will see the error also. So what answer you are getting?
2.21908.
2.219208. Okay. Okay, so that's the answer, and I hope everybody is getting the same, 2.219208. Okay, so if I hope this is correct. So this is the answer, and if you calculate the error, तो exact value जो है 9.2 का, so that is somewhat equal to 2.219203. So that's the exact value. So if we calculate the relative percentage error, true error, then what is the difference? So this is almost 5 5 का difference है, so that means you have 5 into 10 to the power minus 6. 5 into 10 raised to minus 6 divided by this value. So 2.219203 into 100. So if you calculate this error percentage, so this is somewhere close to 0.000225%. That's almost, it is, let's say, of the order of 10 raised to minus 3 percentage. Okay, and if you see, compare this error maybe with our previous Lagrange interpolation, then this may be more higher than that. Okay, so that you, I mean, you study it on your own, you see whether it gives the same thing or not. Okay, so it's very simple, I mean, just mathematical estimations to do that. One can do it by simply making the tables. All right, so we will not be doing much in this problems. I'll give you one example as an assignment, and then we will take next topic. So assignment के लिए, so अच्छा, so it's a whole. So what I'm just giving you this example. So the following data, अच्छा हाँ, I am not going to write down everything. You just write down. Okay, I'm just dictating. So you write down the following data defines the sea level concentration. The following data defines the sea level concentration. Sea level concentration of dissolved oxygen. Sea level concentration of dissolved oxygen for fresh water. For fresh water as a function of temperature. Okay, so what is the data? What I'll just write down here. Charge. I think if I can draw the table, it is better. So I don't know how to make this clear. So yes, okay. So the data is that temperature is given as a function of the oxygen concentration. Right. So over here you have T, temperature, which is in degrees Celsius, and here you have oxygen concentration, which is milligram per liter. Okay. And the data is 0 degrees Celsius, you have 14.621. So 0 degree पे है 14.621. At 8 degrees Celsius, you have 11.843, and 16 degrees Celsius पे है 9.870. ठीक है, 8 पे है 11.843, 16 degrees पे है 9.870, 24 डिग्री सेल्सियस पे है 8.418, ठीक है। 32 पे है 7.305 एंड 40 पे है 6.413. Okay, I hope it is visible to you all. So this is 14.621, 11.843, 9.870, 8.418, 7.305, 6.413. So the question is that you have to estimate oxygen concentration 427. That means at 27 degrees Celsius, what is the dissolved oxygen concentration in the sea water from this data? So O27 that you have to estimate using Lagrange interpolation and Newton's divided difference. Interpolation. Okay, so using Lagrange interpolation and Newton's divided difference interpolation, you have to estimate the dissolved oxygen at 27 degrees Celsius and also estimate and compare the relative error estimate and compare the relative error percentage. Yeah, relative error percentage for both the cases. So this problem you should be doing in the assignment. So if you will be doing this, then it will give you more clear idea for both these interpolations that we have done so far.
सर
हाँ जी,
इसमें ट्रू वैल्यू तो दी नहीं है, तो एरर कैसे फाइंड करेगी?
ट्रू वैल्यू नहीं दी है, सो वो आप यू कैन, अच्छा हाँ, so for that I think what we can do is that you can take an you can take a linear straight line and then you see if you can get it from there.
Okay.
Okay. I mean, of course that there is no as such, but let me see if I have some data from this. Acha, okay, I have the value. So write down this exact value, which is 7.986. Okay, so that is the exact value for the sea level at 27 degrees Celsius. So you can use this data for estimating the error percentage. ठीक है, so let's move on. Now we shall look in the so that's the value you should use for estimating the error. Now we should look for the numeric integration. Okay, so we will see the part of numeric integration. So of course we know how to integrate it with a simple formulas, but there are certain integrations, like if you have something like e raised to minus x squared dx 0 to 1. If you want to do this analytically, then it takes very long steps to do it. So in such cases one may use some sort of numerical methods for that. So there are different methods for this integration. So that is something called rectangular rule, okay, which is a very basic. Rectangular rule, in which simply we actually take the approximate rectangular area to the given curve. So for example, if you have some curve, then we have these data points. We actually take the data points in such a way that it is equally divided between two rectangles. Okay, like that. So we divide the whole integral into the equivalent rectangles to obtain the given integral value, rectangular area. So that is something simply taking this as a function f of x, and you take the integral step h multiplied by, in the sub intervals that you are dividing, f of, actually you can say f of x a, f of x1 plus f of x2 plus f of x3, and up to your f of x. So last point, which is, let's say, b. So if you have this, if you have this integral from a to b, and this step size is actually defined by h equal to b minus a upon n. N is the number of steps. So in how many steps, in how many rectangles you want to divide the whole integral into the equivalent area. Okay, so I guess you have gone through all this in mathematics course, so I'm not going into too much on this. Yeah, but we'll do one example for the trapezoidal rule. Okay, because generally this is very simple one, but the more accurate than this is trapezoidal rule. And even in sometimes in this NET examinations or GATE examinations, you may find the questions from this. So mostly what I have seen is that there is, trapezoidal rules or Simpson's one-third rule, or like that. They do ask these questions from numerical integration. So trapezoidal rule. So again, it is a similar thing. So over here, what do we do is that we take the area under the curve, which is approximated by n trapezoids. Okay, n trapezoids, which actually means what? That you have the curve and we take an average between the two data points. So let's say these are the data points, or these are the steps in which you are dividing this number of steps, n equal h equal to b minus n number of steps, n steps we are dividing. So we take out this area under these n trapezoids, where what do we do? That we actually take the average of the two data points. So which means if you have, let's say, your starting point somewhere here a, that is your the limit b, and in between you are dividing it equally trapezoids, then whatever the area that you are getting, so that means you take the average of first f of a plus f of x1. Okay, so this f of function is nothing but this integral, whatever integral you are taking under the integration parameter, so that your function, that's the first trapezoid multiplied by h. Okay, then you have the second trapezoid, which is f of x1 plus f of x2 multiplied by h. Then you have f of x2 plus x3, and like that you will have at the end f of x n minus 1 plus f of b, that is the last point. All right, so you take an average between two trapezoids. That is actually the meaning of a trapezoid. So when you combine all this, so what formula you are coming up is to, so you are coming up to this formula, which you are denoting it by, let's say, j is equal to, you have, let's say, some function f of x dx, and if you want to approximate this integral by trapezoidal rule, then that rule is the step size multiplied by f of a by 2 plus, if you take, because when you take the summation of all this, तो ये तो दोनों सेम हो जाएगा, मतलब 1/2 plus 1/2 it will be 1, तो यहाँ पे भी 1/2 plus 1/2 वो भी 1 हो जाएगा. So that is going to be f of x1 plus f of x2 plus f of x3, okay, up to f of b divided by 2, मतलब f of xn minus 1, the last one on the step. So that is how one can approximate the given integral. Okay, and this h is equal to b minus a1 n. N is the number of steps. All right. So we should do one example for that. Let's take the same integral. ये वाला जो था, e to minus x square. ये वाला, we take the same integral. So 0 to 1 and e to the power minus x square dx. Yeah, and we want to obtain the approximated value of this integral by trapezoidal rule with 10 steps. Okay, so these are the number of steps given to us. So from that we can find out the step size, which is h equal to b minus a upon n. So that is b and a1 minus 0 upon 10. So this is going to be 0.1. All right. So we can make a table for this. Okay, we can make a table for this, and you have this value j is equal to 0, 1. We will have j, then you will have xj. Okay, because that is there in the function x. So first you find out the x, then you have xj square. Okay, and then you have e to the power minus xj square. So you start j equal to 0, 1, 2, 3, 4. Okay, and up to, you will go to 9, and at the end you will have 10. So you obtain this table. Okay, e to the power. So this is going to be same anyway. This is going to be 0.1. And जो steps, अपने जो steps है h equal to 0.1. So x is divided in the steps of 0.1. So this is nothing but 0.1, 0.2, 0.3. This is going to be 0. This is 0.1. This is 0.2, 0.3, 0.4 up to 0.9 and 1.0. And then you take the square, and then you take e to the power minus xj square. Okay, and at the end you can write down this value over here, e to the power 0. So we know this is it. Achha, so we are writing it up to 6 significant digits. Okay. So we can write down this separately. The reason being that when you're taking the summation, तो लास्ट में जैसे कि यहाँ पे ये जो वैल्यू है, दिस इज गोइंग टू बी समवॉट 0.990050. ठीक है, सिमिलरली 0.9 लास्ट में होगा 0.000444858. So all the values we are writing it on in this column, and यहाँ पे सिर्फ first and last, I mean f of a and f of b. So these two values we are writing it here separately, where with you write 0.367879. That is a value for j equal to 10. The function f of xj, or this is f of b and this is f of a, because we are actually having the summation. We are having the summation here of all this, and f of x1, x2, x4, and this is going to be divided by half, both f of a and f of b. So we are keeping it together. So you take the summation of this at the end. यहाँ पे इसका summation लिख दो, ठीक है, इसका summation यहाँ पे जो भी है, तो this is simply going to be 1.367879. This is going to be summation. अब ये जितने भी terms है यहाँ पे, इसका पूरा summation, so that you write down over here. So I'm just writing it all directly. 6.778167. ये जो भी पूरा वर्कआउट होगा आपका प्रॉब्लम. एंड फाइनली जो आंसर है आपका, सो दैट इज गोइंग टू बी h. अच्छा, सो h का वैल्यू लिख ही देते हैं. सो h इज सिंपली 0.1 है ना, एंड मल्टीप्लाइड बाई f of a प्लस f of b डिवाइडेड बाई 2. इस दोनों, इसका हाफ हो जाएगा यहाँ पे, ठीक है. जो ये जो पूरा है इस 1.367879, so divided by 2, and plus all the terms f of x1 plus f of x2 plus f of x3 plus x4, 5, 6, 7, 8, 9. So all those summations are approximated by this trapezoids. ठीक है, so you just work out this well and you should get an answer somewhere close to 0.746211. ठीक है, so you should be getting all of you should be getting these answers. Acha, so okay, so that is the answer. And now for the error part, we will see that how this error is actually estimated in this particular problem. So generally for this trapezoidal rule, the error is estimated by taking b minus a by 12. So that's the formula for this error. I'm writing it directly. H square f double prime of your function t. Okay, this is the time interval. The time interval means, or the limit interval that we have. Like in this particular case, it is 0 to 1. So this is how the error is actually estimated. And it is between minus and plus on both the sides. So let me just take an example of this problem only जो अभी हमने किया है. So in this case, if I want to put up an error bound, what are the error bounds on both the minus and plus side? So for that, I'll need the first and I'll need the second derivative of this function. So e raised to minus x square. So पहले तो first let me take the first derivative f prime. So that is equal to e to the power minus x square into minus 2x. ठीक है. But we need the second derivative according to the definition. So second derivative of x. So you have the integration by part. So e raised to minus x square integration. Differentiation by part. So this is going to be minus 2 plus minus 2x into e raised to minus x square into minus 2x. Alright. So this is going to be, if I'll take 2 e raised to minus x square common out, then you are going to have 4x square minus 2. 4x. Anyway, so you just ignore this, and this is going to be your f double prime, and now you multiply it by this factor. So now these are the, it is a time interval, as I said. It is a time interval or the limit interval. The limit is between 0 to 1. Okay, so for that, so this is limit. So 0 to 1. So you have for first x equal to 0. You have m. Let me just write down it by some bound m2 star, which is f double prime 0. Okay, so that is going to be equal to minus 2. And for the largest value, so this is the smallest value of the time interval, this is the largest value of the time interval. So for that, I'm writing f double prime 1. So I substitute the value over here, e raised to minus 1 and 4 minus 2. So minus 2 into minus 2 divided by e. So that is going to be minus 2 divided by minus e. So that is going to be equal to somewhere close to 0.735759. Okay. So for that, you will have the error estimate. Generally, it is given by, so I have just taken some symbols. M2k less than epsilon t less than M2 star k. K is nothing but this factor, this one. So k is equal to b minus a divided by 12 into h square. Okay, so that is the factor that we are having. So this is going to be 1 minus 0 by 12 in 2.1 square. So we are going to have 0.1 square. Okay, so for that, if you just calculate this is going to be minus 0.0000833. Okay, to work out this thing. And then you simply multiply it by our lower and upper limits, this M2 and M2 star. And then you write down this whole limit error bounds. This is the lower bound, as the upper bound. So for that, one would have the limit into, if you write down the values of M2 and K, then you are going to have 0.77375, 7375, 735, 735,759, 759 value of M2 into this value of K less than epsilon T less than you have -2, you have actually it should be minus, less than or minus, you will have minus less than or equal to, so you will have -2 into this value here. Okay, if you work out this, your final error bound should be 0.000613 less than or equal to epsilon T less than or equal to 0.001667. So this is the error bound. It is called error bound. So you should be able to find the error bound as well for the given problem. है ना, ऐसा नहीं है इसमें कि चलो तो सिर्फ कैलकुलेट करना है कैलकुलेटर से. I mean of course पूरा न्यूमेरिकल तो ऐसा ही है. All this simply make the table, find out the function's value, put it in the equation. जो equation हमको यहाँ पे दिया है ये, है ना, इसमें सब value डाल के you will find out the value of the integral. But the important is to analyze the error also. So this is the error bound that you should be able to obtain. ठीक है
सर वहाँ पर 2 इग्नोर क्यों किया था?
हाँ जी,
2 इग्नोर क्यों किया था वहाँ पर एफ डबल डैश में?
कहाँ इग्नोर किया है ना, ये रहा.
हाँ वो वाला.
अच्छा लिखा ना -2 इंटू दिस वैल्यू, है ना, M2 स्टार इंटू के, और ये M2 इंटू के है. तो जो भी ये वैल्यू है M2 स्टार -2 मल्टीप्लाइड बाई दिस वैल्यू, ये यहाँ पे मतलब मैंने लिखा नहीं है ये वैल्यू, बट यू हैव टू मल्टीप्लाई दिस टू, सो ये इतना वैल्यू मिलेगा आपको. ठीक है, सो that is how we find the error bound. And so tomorrow we will see, maybe next time we will see the Simpson's 1/3 rule. So we'll just take an example and we'll just move ahead. We're not spending too much of time on all this. So Simpson's 1/3 rule, and then we will just complete this numeric integration part. Then we will have something, maybe numeric differentiation. All right, so if you have any questions, you can ask. Because I think ये सब आपने किया हुआ है पहले तो, but it is there in our review part, so we are just taking one example each. And हाँ, इसके लिए एक example है, but I will give you tomorrow. ठीक है, इसका जो भी assignment example है, so I will give it you tomorrow. अच्छा, कल तो lecture नहीं है. Okay, let me just give it to you now. It's take this in the assignment 0 to 1. वो simple है, x square dx with h equal to, take, अच्छा, you have to take different steps, 0.25 and then 0.1. Okay, so you have to do this, you do this example in three different ways. First you take only 2 steps, okay, and then you have 4 steps, then you have 10 steps, and then you see how the error is actually changing as you do all this practice. And ये वाला I think not last, but I think couple of years ago it was asked in the NET examination. I mean, not just simply calculating the value, but there was some question MCQ based on this type of integral, where you were supposed to find out this value in only 2 steps, and you were supposed to find out the lower error, or I mean lower error bounds. There was some questions, I don't remember exactly, but I think in 2018 नेट के पेपर में था ऐसा क्वेश्चन. So okay, ये आपको असाइनमेंट में करना था. Assignment. So take it with 3 different step sizes, 1, 0.25 and 0.1. Okay, so thank you for your attention and have a good day.